students, today we will discuss the electric field lines and their properties. Electric field lines are the hypothetical lines which are used for representing the electric field in a certain space. Now, some main properties of electric field lines are that they always originate or start from positive charge and end at negative charge. So, if we take and isolate positive charge, so they will go from the position of charge radially outward. Similarly, for negative charge, they will go radially inward. Now we can say they always start from positive and at negative. That's why they never form closed loop and they don't have sudden breaks. Unless until there is some negative charge, they will not end. So this type of question they can ask normally in 1 marks. This was there in this year's paper also. Second thing is tangent at any point on the electric field gives the direction of electric field at that point. Now you know this sort of question was also there this year in 1 mark. They have asked why two electric field lines never intersect. You know, if they intersect, there will be two directions of electric field at the point of intersection, which is not possible. So they never intersect. Next, we say if the electric field lines are parallel to each other, that means uniform electric field, means we represent them by parallel lines, and if they are converging or diverging, then that means non-uniform field. Like for example, in this case, they are going towards a point, we can say converging, we can say electric field is increasing in the forward direction. Next, if we have to draw the electric field lines for two identical positive charges separated by a small distance, in that case we have to apply the logic that the region where electric field is maximum or more, there the electric field lines will be closely packed, and where they are widely separated, then there the electric field will be weak. Now in this case, if we are having identical positive charges, then we have to check in which areas or which region electric field is strong and which area it is weaker. Say for example, if we take any point on this side, then this charge and this charge both will repel. So outward side, both the electric field means due to charge 1 and 2 both are in the same direction. Similarly on this side, they are there in the same direction. So the two fields are being added up, but in the region between the two charges, this field will repel and this one will repel. So electric field due to two charges are in opposite directions. So net field in the area between the two charges is E1 minus E2, and at the midpoint the value will be 0. So when we are showing the electric field lines, then in this area where the field is strong, we are showing comparatively more lines, here comparatively lesser line, and at the midpoint where electric field is 0, no line we are showing. Similarly, if we have to draw it for the electric dipole, or you can say two equal and opposite charges separated by a small distance, again the same logic we will apply. From positive charge they will go outward, from negative charge they will go inward. Secondly, we have to check where the electric field is strong and where it is weak. So near the location of point charge, the electric field is strong, and we know they will start from positive charge and at negative charge. So outside they are similar to the magnetic field lines which we have drawn for the bar magnet. Then we say next, electric field is 0 inside a conductor, means no electric field line will pass through a conductor. So at times they can ask you to draw the electric field line for a conducting sphere. If we are showing conducting sphere, then two properties we are having: inside the electric field line will not go, means because it is 0, and they are always normal to the surface of conductor. Now this property, they are always normal to surface of conductor, we will discuss in the topic electric potential also. Similarly, if we are having a conducting shell and a point charge is placed at the center, then they will go radially outward, but this way inside the conducting means shell surface part, there the no field line is there. Now this positive charge will induce a negative charge on the inner surface and positive charge on the outer surface. That's why we are saying they end at the first surface, and from the outer surface they always are again start from going outward. Similarly, if we have to draw the electric field line for the positive point charge placed near a conducting plate, then you know they are going outward. On the surface of conductor, they will strike normally, and it will induce negative charge on this surface, so they will end, and opposite side it will you can say generate or induce the same charge. So now again they are going outward, normal to the surface of conducting plate. And this we have shown for a normal conducting plate which is positively charged. So they are going outward from all the sides and normal to the surface of conductor. Now